Let's work on finding slopes of lines from both points and from graphs. I'm going to go ahead and start with this example here. I've got this graph. Now the slope really tells me how I get from one point to the next and gives me some information about how steep this line is. So as I'm moving from the point 0, 0 to the point 2, 4, I want to find how far it went up in the y direction. So that would be 1, 2, 3, 4. So that would be plus 4. We call that our rise. And then how far also I had to move in the x direction. And in the x direction, to get to that second point, I had to move 2 spaces plus 2. This is the run or the x direction. Now we go ahead and denote slope with the letter m, and my rise or change in the y direction is 4. My run or change in the x direction is 2, and 4 divided by 2 is 2, and that's our slope. The slope of the line is the change in the y direction over the change in the x direction, which we also saw as rise over run, but there's a really nice formula to find that rise or the change in the y direction. I'm just going to subtract the second y coordinate from the first y coordinate. Those are from my 2 points, and then divide that by the difference in the x's. Really what our slope is overall is a number that describes the steepness and direction of that line. Here comes another example. Now I'm going to use the formula, but let's plot these points as well. In order to use the formula, I really need to know which one's going to be my point 1 and which one is my point 2. It really doesn't matter. We're going to get the same answer either way. I've got these 2 points plotted. Now I can go ahead and find the slope of the line that goes through these 2 points by finding how far I've got to change in the y direction. That would be 1, 2, 3. And then divide that by how far I need to change in the x direction, which would also be 1, 2, 3. So using this method, I get that my slope is equal to 3 over 3 or 1. Let's also verify this using our formula. So using our formula, m is equal to the difference in the y coordinates. So I'm going to go ahead and pick up 1 as my second y coordinate. So this is going to be y2, and then 4 as my first y coordinate, y1, just because of the way I labeled them. You can definitely turn this around. I want a minus sign in the middle, and I want that second y1 minus the first y4. Now let's do our x values. Now the first x value, the way I labeled it, is going to be a 2, and the second x value is going to be that -1. I want the negative sign in the middle. X2 is a -1, and x1 is a 2. If I do the math here, I get -3 over -3, and -3 over -3 is also equal to 1. So if it's not too much trouble, graphing it is such a nice way to go. But if it's a little bit of work, you can just dive right into that formula. In this next one, I'm not going to bother to graph it. Instead, I'm going to go ahead and just start by labeling these as a point 1 and a point 2, and let's dive right into that formula. So m is equal to the difference in those y coordinates, and I want to pick up the second y. The second y is a 2 from point 2 over there, and the first y from point 1 is a -1. And now let's subtract the x's. I'm going to pick up the second x first, which is a 3, and the first x, which is also a 3. These two negative signs become plus, so in my numerator I get 2 plus 1, or 3, but in my denominator I end up with a 0. So we get 3 divided by 0, which is undefined. You can use the empty set, or you can say that this slope is undefined. This turns out to be a vertical line. Here's our next one. Again, I'm not going to bother to graph this one, but I'm just going to dive right in and label these as point 1 and point 2. So as we're computing our slope, I want the difference in the y coordinates over the difference in the x coordinates. I'm going to start with point 2's y, which is a 2, and then point 1's y, which is a -1. Now let's move over to those x values. -3 is the second x value, and -2 is the first x value. Now notice how I kept the negative sign from my formula separate. That way I'm not going to miss any negatives. Okay, so what do I have? In that numerator, I really have 2 plus 1. In that denominator, I really have -3 plus 2. So I end up with 3 in my numerator, -1 in my denominator, and my slope m is equal to a -3. So we've seen a couple of different types of slopes. We have seen a positive slope. A really good analogy is thinking of a skier. So if you are reading that graph from left to right, that skier is going up on the chairlift. Negative slope means that the skier is skiing downhill. I'm going to skip over this third one for a second, and I'm going to go to the last one. So now the skier is down there at the lodge, just kind of scooting around, maybe making their way to the chairlift. That last one, though, straight up and down, oh my gosh, what is that skier doing now? Well, they probably fell off of the chairlift or something. Whatever it is, it's not good, and we call that an undefined slope. So we've got positive, negative, undefined, and 0. You guys are doing fantastic. We're going to take a look at x and y intercepts in my next video. Thanks so much for watching.